P.2, page 14, graphs of equations. All right, we start off with a couple of bold print terms that are important here. The first one is solution point, and we actually talked about that in the last half of section P1. We said that a solution point was a point that you could plug into the equation and it made the equation true, right? It was a solution for the equation. And we also mentioned that if it was a solution point then, that it would be on the graph of that equation. And so those are our bold print terms here, solution point and graph of the equation. So example of that is, let's say that we had the equation 3x plus y is equal to 5, and we wanted to find some solution points for that. You could pick any x value that you want to and plug into that equation, and whatever makes that equation true, whatever y value it takes to make that equation work, is going to be a solution point. So if we put 0 in for x, what would y have to be to make that true? 5. So 0, 5 would be a solution point. How about if I plug in 1? 2. How about if I plug in 2? How about if I plug in 3? All right, so all of those 4 points are going to be solution points. We could be here all day long because there's an infinite number of these, right? If I plot those solution points, they will generate the graph of the equation. And so that would be the graph of the equation 3x plus y is equal to 5. So the solution points will be on the graph of the equation. We can use the solution points to generate the graph. The converse of that can also be helpful for us because the example 1 says, is 213 on the graph of y equals 10x minus 7? Do you actually have to graph that to figure it out? No. What could you do? Plug it in. If I plug it in, I can see if it's a solutions point, and that would tell me if it's on the graph. All right, so if I'm going to plug that in, I'm going to put 2 in the place of x and 13 in the place of y. What am I looking for? Yeah, are they equal to each other? So when I get the 13 equals 13, what does that mean? Is this on the graph or not? Yes. Yes. If I had gotten something like 13 equals 27, then no. All right? So example number 2, they ask us to actually sketch the graph by plotting points. Now, sometimes when they do this, they're going to give me a preset table of values that they want me to utilize. So in this case, they told me the x values that they wanted me to use, and they want me to find the y values. So for the first one, if I've got -1, if I take -1 and I put it in place of x, that would be 3 times -1, or -3. So I've got -3 plus y equals 6. Add that 3 to both sides, and I'll get y equals 9. And so that would be my ordered pair, -1, 9. So go ahead and finish that table and see what you get. Go ahead and complete that on your own there and see what you get. All right, so what'd you get when you plugged in 0?
6.
How about when you plugged in 1?
3.
2?
0.
And 3.
3.
So all of those are solution points, and all of those, if I were to plot those, they would be on the graph of the equation. Now, if I recognize that I'm working with a linear equation, how many points do you need to graph a line?
3.
Yeah, 2 or 3. So if I get to graph this any way that I want to, and I recognize that it's a linear equation, I'm just going to plot 2 or 3 points. The easiest points for me personally are the x and the y intercepts. They'll actually talk to us about this in another day or two, but just for a reminder, you can find your x and y intercepts, the places where the graph crosses the x and the y axis. You can find those by putting 0 in for x and 0 in for y. So the reason that I love those so much is that if you put 0 in for x, it's literally like this whole piece of the equation drops out. So it's like you can put your hand over that part of the equation, and all you have left is y equals 6. So it's easy to see what other value should be. Same idea if I put 0 in for y, it's like you could cover up this part of the equation, and all you have left is 3x equals 6, and you can do that in your head and get x equals 2. And although we can get away with just plotting 2 points, I'm really bad about careless mistakes. And so I plot a third point just to make sure that they're all lining up correctly and that I haven't done something stupid and made a mistake. So I would give myself just one other point. So you can see those are 3 of the same points that you generated over there, but in this case we got to choose which ones we wanted and do it on our own. So we said if it were linear, I would only need 2 or 3 points. How do I tell if it's linear? Okay, x is a power of 1. What about y? Y is also a power of 1. So I'm going to have a linear equation, meaning that it's going to graph as a line. Root word of linear is line. I'll have a linear equation, meaning it graphs as a line, and I only need to plot 2 or 3 points if I have x to the first and y to the first, or maybe just one or the other. Like maybe I just have x to the first or just y to the first, like x equals 3 and y equals 4. Those are still linear equations. I'm okay with that. Now, when we talk about lines, lines are straight paths. I can't draw a straight line to save my life. So I plot my points and then I get out my little straight edge and I play dot to dot with my straight edge to try and make this nice, clean, neat, straight path. And every time I do that, it reminds me of one of my favorite set of verses, which is Proverbs 3, 5, and 6. And it says, if we just trust in the Lord with all of our heart and lean on His understanding instead of our own, because most of the time I don't understand why things happen the way that they do. If I just put Him first in everything I do, then He will lay my path straight out in front of me. I don't draw a straight path for my life much better than I draw a straight line on a piece of paper. I draw bad stick figures, and I don't always make the best choices and the best decisions when I'm left to myself. So I love this verse because I don't have to know what the right thing is for me. I don't have to know what college I'm supposed to go to, or what I'm supposed to major in, or who I'm supposed to marry, or what I'm supposed to do with the rest of my life, or, those kinds of decisions that you're facing in the near future that are just daunting. You don't have to worry about any of that. You just trust in the Lord with all your heart, and He will flat lay it out straight in front of you. It's a promise that He makes us that we can count on. So every time I'm getting out my little straight edge and I'm drawing my straight path, it's always such a cool reminder to me that just like I need help to do that and I need a guide to do that, that I've got a guide for that in real life too. So I love it. So we mentioned example number 3, that the book asked us to plot like 5 points. We just plotted 3 points because we thought that it was linear. And we had the discussion that it was linear because it was x to the first and y to the first. All right? But what if I had something like what they give me on page 16? Like 1/30th x times x to the 4th. That's like some crazy quintic thing. And in example 3 in the book, they give me y is equal to x squared minus 2. Neither of those are linear. If it's not x to the first, y to the first, it's not linear. And I'm not going to get away with just plotting 2 or 3 points. As a matter of fact, if you look over on page 16 at that crazy equation, that 1/30th x times x to the 4th thing, they started off by plotting what we probably would think was plenty. They made a table and they plotted 5 points. I mean, goodness, 5 points is enough, right? And they graphed it and they thought they had a pretty good picture of what that graph looked like. And then if you'll notice in figure B right beside it, yeah, that wasn't anything like what that graph looked like. It actually needed more like 10 or 15 points to get a better idea of what it looked like. And so that's the problem with point plotting. I can plot anything on the face of the earth if I just plot enough points, but how in the world am I supposed to know what's enough points? How do I know when to stop? And so that's where a graphing calculator can be really helpful. And so for example number 4, they asked me to use a graphing utility to graph my equation. Now, if you're going to put something in your graphing calculator, you have got to solve it for y first, because we put it in y equals in the calculator. So for example 4, let's solve that for y. What do I need to do first? All right. Subtract x cubed over to the other side, then what? Divide by 2. And I'm going to simplify that a little bit before I throw it in my calculator. So I'm going to go ahead and say 4 divided by 2 is 2, and that 1/2 x cubed. So I've written that equation here on the board for us so that we've got it. So grab your graphing calculator if you would. And you're going to turn your calculator on down here in the bottom left-hand corner. We're starting from scratch, right? So you're going to go to y equals. That's this button right here in the top left corner. And you can type in your equation. Clear out anything that might be in there. And we had 2x, so your x button is right here. xt theta n is your x button. Please notice the difference between your subtraction and your negative. I do have to do minus, not negative. So minus 1/2 x to the third. I have a habit of just putting my fractions in parentheses so then I don't have to worry about order of operations. Sometimes I need them in parentheses, sometimes I don't. I don't even stop and think about it. I just put them in, or I write it as a decimal instead. Now we have x to the third. So when you hit this little caret key right here to raise to an exponent, mine automatically jumps up to a superscript. If yours does that, you have the new operating system for the 84. If yours does not do that and you have a TI-84, it will literally like type on your screen X and then that little caret key and then a number 3, okay? If you have a TI-84 and your calculator typed it with that caret key and it did not jump up to a superscript, you do not have the new operating system, and I promise you, you want it, and I can give it to you in about 5 minutes. See me about that. If you have an 83, I can't give you the new operating system, okay? All right, so that's how you'll know whether you have it or not. Okay, so I'm going to graph, and when I graph, I'm just going to come right over here to hit my graph button. And you can see it probably would have taken me quite a few values in an XY chart to come up with an accurate graph for that. Now, if you're looking at that and going, my graph does not look like that, then it's probably because we're on different zooms or we have different windows. It's kind of like if you were looking at a picture and I was looking at a picture and I was zoomed in and you were zoomed out, we wouldn't see the same thing. So I'm going to come over here to zoom on my calculator, and there are actually 3 zooms that I want to talk to you about today, number 4, number 5, and number 6. When I first graph, I usually go to a zoom 6. That's the standard. So like if you were drawing a graph on your paper, you probably would go 10s all the way around. That's exactly what this does. It goes 10 up, 10 down, 10 left, 10 right. That's a little far out for our particular graph. I'd really rather see a more closer up view. And if I trace on a zoom standard, I'm going to get like crazy decimals. I mean, if you'll notice, I've got like, 8 decimal places on those when I trace. So if I go back to zoom in, this time I choose number 4. For number 4, that's a zoom decimal. It's a closer view, and additionally, when I trace, it gives me nice, even, neat numbers. Like you'll notice, it's going 0.1, 0.2, 0.3, 0.4, 0.5. That's why it's called zoom decimal. I get normal numbers. Those are probably the 2 I use most often if I need a larger picture or if I need a smaller picture. The only thing that is bad about the calculator is that sometimes it can skew your graph. Like it's a whole lot longer this way than it is deep this way. And so look at your tick marks. To go 10 this way, see how much further apart those bars are than to go 10 this way. See how those are much more closely grouped together. So like if I graph a circle, it's going to make it look like an oval instead of a circle. It won't always give me a true representation. So the other zoom that I want to mention to you today is a zoom square. And that's right there, number 5, the one that's in between those other 2 we were just looking at. If I choose zoom square, it will square off that screen so that it makes the tick marks the exact same distance apart. And then I get a more accurate picture. And it depends on what I started with. Like if I started on a zoom 4, where I was closer up, and then I squared it off with that zoom 5, then it would square the screen off that I was on. So if I wanted the closer view or the further out view, I could still get it squared off. Now, tonight on the homework, they're going to have you doing some graphing on your own, and there are a couple of buttons that they're going to expect that you know where they are. So let me make sure you know where these are. To begin with, they're going to ask you to graph something that has a cube root in it. So I went to math, and you'll notice there's your cube root right there. Additionally, they're going to ask you to graph an absolute value tonight. So while I'm in math, you see I have these other options up here across the top. So I'm just going to use a right arrow key to go over to number, and that first one right there is absolute value. So just for review of what we just looked at, once we had that equation in a form of y equals, we typed it into y equals in our calculator. We looked at a zoom standard and then we went to a zoom decimal. This was our zoom decimal, and we even played around with squaring it off when we needed to. And we talked about what the graph of a cube root and an absolute value, where we would find those buttons on our calculator, because we're going to need them tonight. Now, this graph, so much easier to do on my calculator. But I think we get this idea that everything is easier to do on the calculator, and that's not necessarily true. Like, look at the next one. Example number 5, we've got x squared plus y squared equals 9. Is that linear? No. What is that? It's a circle. X to the second and y to the second. That's what we looked at last week, right? X minus h squared, y minus k squared is equal to r squared. What is the center of that circle? 0, 0. What is the radius? 3. How long would it take you to draw that by hand? 10 seconds, right. It's going to take me probably about 2 minutes to get that in my calculator. Okay? Calculator is not always the best way to do this. Why would it take 2 minutes to get in my calculator? Because I got to solve it for y first, right? So I got to do some paper and pencil work. So to get y by itself, I have to insert a square root. What do you insert when you put in a square root? Plus or minus, right? So when I go to graph that on my calculator, there is no handy-dandy plus or minus button on my calculator. I literally have to enter it as two completely separate equations. So I have to enter the positive radical in y1, and then I have to enter the negative radical in y2 before it'll be able to generate that circle. And when I first type it in, it's not even going to look like a circle. It's going to look like an oval until I go back and I rezoom using that zoom square feature. Again, 10 seconds by hand, right? Okay, so calculator not always the best method. And just a reminder here that we've talked about zoom decimal, zoom standard, and zoom square today. So tonight when you're on the homework, play around with those a little bit, because they are going to have you graphing some of these by hand, but then they will tell you to graph some of these on your calculator. So maybe start with a zoom standard. That's the 10s all the way around. If you need a closer view, then try the zoom decimal. On a couple of the problems, they may say use the square feature on your calculator to get a true picture. That's that zoom square button that they're talking about. So play around with those a little bit and get a feel for what you're comfortable with. All right, they always like to leave us with a real-world application so that we can understand how what we're learning would be relevant to everyday life. So it says a runner runs at a constant rate, example 6, a runner runs at a constant rate of 4.9 miles per hour. The verbal model and algebraic equation relating distance run and elapsed time are as follows, and it's just distance is equal to rate times time. We've been using that for years, so we're comfortable with that. Since they told me that the runner runs at a constant rate of 4.9, then I could replace rate with 4.9. Now, if that is bothering you that you've got like a D and a T in there, you could always replace that with X and Y if it makes you feel better. It's still x to the first, y to the first, just like a linear equation that we've been working with today. If you wanted to throw it into your calculator to look at the graph, that's how you would put it in. So don't let the d and the t bother you. They're just variables. So for the first one, it says, determine how far the runner can run in 3.1 hours. What is 3.1 hours? Distance, rate, or time? Time. So let's put 3.1 in for time. If I do that, then the only unknown would still be my distance, which is good because that's what they asked me to find. So I can multiply 4.9 times 3.1 and find out that I run 15.19 miles in that time. The second question they asked me is determine how long it'll take to run a 26.2 mile marathon. So if that's my pace, if I'm running 4.9 miles per hour and I got to run 26.2 miles, how long is that going to take me? So again, I'm starting with that same equation that distance equals 4.9 times t. What am I putting 26.2 in for? D, yeah. So let's put 26.2 in for D. How am I going to find the time? divide by 4.9. So if I divide that by 4.9, I find out that it's going to take me a little more than 5.5 hours if I can keep that constant rate. Okay. All right, so here is our homework for tonight. On pages 21 to 23, we're doing 1 through 53, every other odd. Be sure you get that other in there. If you need to literally make a list, on the inside of your notebook, you could go through and make a list of all the odd problems, because we do every other odd so often, and go through and cross off like every other one for yourself, so you don't have to do that every time you do homework, but whatever you want to do. And then also 59, challenge 71. Now, in the book, when you have 25 to 35, it says sketch the graph. That does not mean put it in your calculator. That means sketch it by hand. So no calculator on those. But then when you get to the next section, 37 through 50, it says use a graphing utility to do these. So we'll get practice with doing it both ways. Okay?